So let's go over all these problems. And I suggest you pause and try on your own, then play the video so you can see how I go over. So please actively try this problem on your own, because one of the things that helps us learn is practice thinking about these concepts in our own minds. So even for this verse 2, please pause the video now, try on your own, then see what I do. So just try to construct these two angles. So first one, construct radian, 1 radian. So we think about it as 1 radian means that if I have a radius of this length, let's say I call it r, the arc length created by this angle, let me do it better, is also this length. This arc length is also r, same length. And now we have the angle measure of 1 radian. This is 1 radian. Two radians mean that we have 2 radius length. So standard position start from here. I have 1 radian is about here. And let's go another one somewhere here. So I have arc length is twice as large as the radius length. So there's r and r. So this angle right here is 2 radian. So it is important for us to be able to picture angle measure using idea of radians, using radius length as a unit measure. We're using radius length to measure the arc length created by the angle. Explain what an angle of 1.5 radian means in terms of radius and arc length. So again, please pause the video and try on your own first. So 1.5 radian means that the arc length is 1.5 times as large as the radius length. So again, we're using the length of radius to measure the arc length. So if I have radius length of, let's say, 10 centimeter, 1.5 radian means that if I measure this arc length, this will be 15 centimeter. Oops. Let me do it like this. And this is the angle. This angle is 1.5 radian. So we need to be able to construct the angle measure using radian without relying on degrees, because it's important for us to understand this, how this angle is measured using arc length and the radius length, because that becomes important when we define sine and cosine functions. Okay, so draw the following angle in the standard position. So standard position just means we're drawing in x and y coordinate. So let's do one at a time. 217 degrees. So we know that each quadrant is 90 degree. So here to here is 90, 180. So let's draw a initial ray. So initial ray is all start from here. So we have 180, and if I come all the way to here, this will be 270. So we need to, the angle is in third quadrant. And it's, again, we're kind of estimating, so maybe somewhere here. We can say this is 217. So I'm going to just mark it A. So when we draw degrees, we do have to rely on our benchmark of degrees. We know what 90 degrees look like. We use that idea. We can also kind of picture what 45 degree is in our head. But when we do a radian, so this one is radian. All these are radian and radians. So 4 pi over 3. So that means that the arc length created by the angle is 4 pi over 3 times as large as as a radius length. So it helps us if we can get an idea of how big of number this is. So pi is about 3.4. So we have about, in terms of, we have 12 something, 12 and some decimals. But what matters is 12. So we have number close to 4 point some decimals. Because we're doing 3.14 times by 4 will give us 12 point some number. Divided by 3 give us about 4. So it's close to 4 radian. So let me draw in green. So 4 radian. So you pick a radius. So let's just do same length. Initial ray. So 4 radian will be, so here's 1 radian. Let me draw it better. Here's 1 radian, 2 radian, 3 radian, 4 radian. So somewhere here. Maybe we'll have to go a little more than 4, the decimal amount. But again, we're still just estimating. So this angle right here is B. And pi is about 3.14, and pi is just, let me draw pi. Pi is just from here to here. This is pi degree. In pi radian, sorry, excuse me, pi radian. 16 power 7, same idea. What we do is, in order to get an idea of what whole number this is close to, so this is 16 times 3.14 divided by 7. So this gives us about 48 or 49. Because we're estimating. So we know that 16 times 3 gives us 48. But because there's decimal, let's say it's close to 49. Again, we're estimating here. So it's about 7. So 7 radian. That means that we go over full rotation, right? Because full rotation is 2 pi. So full rotation is about 6.28 radian. Then we have to go 1 more radian. So that's this one. Let me draw with this color. So let's start from here again. So let's use this one: 1 radian, 2, 3, 4, 5, 6, then maybe 7 somewhere here. So this angle is D. I know it's hard to see, but again, once we look at unit circle and later in this page, it will be easier to identify the sum of these angles. But for now, we're just trying to practice the ways of thinking we need to understand the idea of radian to use measure angles. And 145 degree, 150 is somewhere here. Let me draw green. 150 is somewhere here, so you can go a little less than 150. Okay, so for these one, I suggest you, I know I kind of drew an all one, but try on your own and 5 different coordinate. Okay, now let's look at this. Again, pause the video and try on your own first. It's okay if you get it wrong, because I'll go over it right now. So please pause the video and do your best. Okay, so draw an angle, theta, such that cosine theta is positive and tangent theta is negative. So this is where we really have to think about the definition of cosine theta. Cosine theta it measures horizontal distance from vertical diameter. So that means we need to have a circle. So let's have a circle. So we have a vertical diameter, this one right here. And our horizontal distance from this vertical diameter is positive. So that means that it has to be right side of this line. So it'll be somewhere, all these are positive distance in terms of x value, right? So for now, we have first and fourth quadrant as a candidate. But then we look at tangent. What does tangent measure? Tangent tells us the slope of the terminal ray. Created by this angle theta. So here the terminal ray slope is negative. So if slope looks this way, this direction is all positive slope. If we go this way, it's all negative in terms of rise over run, change y over changing x. So slope has to be somewhere in fourth quadrant. So that means that angle must be in fourth quadrant. Like let's say, okay, we're just picking one angle. So let's say draw an angle. So I'll start from here, then this angle right here. This theta will give us cosine theta of positive, because even if I have this, then the horizontal distance from vertical ray is positive. And slope of this red line, this terminal ray, is negative. So this is an angle that will give us cosine theta positive, tangent theta negative. Similar problem, just different trig functions. So again, pause the video, try on your own, then come back. So here we have sine. What is sine? It's the vertical distance. The output represents vertical distance from horizontal diameter. So let me draw a circle again. Doesn't look like a perfect circle, but you get the idea, right? So here we have horizontal diameter, and the distance is negative. That means that we have any either third or fourth quadrant. So all these distances are negative. So our terminal ray, the angle must be either in third or fourth. But now let's look at cotangent. Cotangent, first we have to know that cotangent theta equals 1 over tangent theta. So essentially we're seeing if cotangent negative means that we want tangent to be negative. That means slope is negative. So slope is negative in fourth quadrant again, just like the previous one. So maybe I can draw an angle right here. So here's the initial ray all the way like this. So we happen to have a similar answer as the previous one, but the way in which we went about it is a little different because we're dealing with two different type of trig functions. So we want tangent to be negative because in order for cotangent to be negative, tangent has to be negative. 1 over negative will give us a negative number. So again, this is just one answer. There, as long as you draw any angle in fourth quadrant, that will be a correct answer. Same thing for number 5 as well. Okay, so let's look at this problem. So let's read the problem first so we can understand what the problem is asking. And then I'll kind of give you a tip on how to approach this problem, and I'll have you pause the video, try on your own, then you can watch and continue to watch to see what I did. So Monica and Louis go to a fair and decide to ride a Ferris wheel. The Ferris wheel operator tells them if they keep track on how far they had traveled while in their seat, they'll win a prize. The catch is that they have to be able to tell how far they traveled anytime he asks for it. The only information he gives is that Ferris wheel radius is 35 feet. After agreeing to the challenge, Monica knows that there are total 12 carts equally spaced around the Ferris wheel, and Louis and Monica are also the first group to board. So make a drawing of the situation, illustrate quantities in the diagram, label the location of Louis and Monica boarding the Ferris wheel, as well as the location of Louis and Monica when the last card is filled. So we're going to do A together. Then I'll have you try B by yourself. Okay, so let's draw it first. So I'll draw a circle and a X and Y coordinate. So there are 12 of them. So here's a cart. So this is where this is the start when Louis and Monica get on. Okay. They're equally 12 space one. So we have like this. Let me draw all these. So equal space. So I'm just going to draw a circle to be faster. All these are cards. And let's make sure to count it. Oh, I missed one here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is start, and when the last card is filled, because each card is filled one at a time, this one, so they'll move this direction. Let's say they move this direction. So Louis and Monica will go to this position, right? When they rotate. So we go all the way around. When all the cards filled, Louis and Monica will end here. This is the ending point. Ending is in this is the position when the last card is filled. And what is the quantity? Label the location with labeled it, and that's the quantity. So the quantity, how far they traveled, what we need to do is we measure the arc length. That's what we need to do. Right, the arc length. Like this. So, and it also tells that the radius is 35 feet. So this length is 35 feet everywhere. So let's look at part B. So let's read it together so we can understand the problem. Then you can think about the main idea. After the operator filled the 4 card totals, including Louis and Monica's, he asked them for distance they traveled. What is the length of the arc in feet traveled by Monica? Okay, so this is one question. And also a measure in radius length. Label this measurement on the diagram. Explicitly identify arc length being measured. So since 4 cars, there is 1 Monica and Monica's field here. 2, they move here. So they move here. Then second one field, they move here. Third one field, they move here. Fourth one field, right? So we have 4 cards field, including Louis and Monica. So 1, 2, 3, 4. So we're actually measuring this arc length. Maybe highlight it. So how can you find this arc length? So pause the video and see if you can figure it out. Then once you tried, you can come back and I'll go over it. Okay, let's see. So we need to have an idea in our head what radian this is. because we're measuring arc length. So this is pi over 2. So this arc length is pi over 2. So arc length in radius length is pi over 2. That means that this arc length is pi over 2 times large as large as the radius length. That also means we're essentially, for this part, we are measuring this angle right here. Just the amount of angle measure, which is pi over 2. So now how can we actually calculate the arc length using feet? So let's do arc length in feet. Since arc length is pi over 2 times as large as the radius length, we just multiply by 35 feet. So answer is 35 pi over 2 feet. So that'll be the length of this. Let me do this. This part right here, this is the length in feet, because radius length was 35 feet. We just multiply by the angle measured in radian. So this is a really good problem for us to think about the application of radian. And also we can even go further of how we can measure the horizontal distance travel and vertical distance travel using sine and cosine as well. But for now, just really try to think the angle measure as a radian. And you can also try, if you want to try more, you can also try what happened after 7 cards filled. Right? You can try this on your own. What's including Monica and Louis after 7 cards filled cards. What's the total distance they traveled? Okay. Okay, let's go to the next problem. So pause the video, try on your own, and come back. So here a 15 feet ladder leans against the building so that the angle between the ground and the ladder is 45 degrees. How does the ladder reach? How high does the ladder reach on the building? So here it helps to draw. So this is building. And we have a ladder between the ground is 45 degrees. 45 degrees. And ladder is 15 feet. And we want to find this height. Let's call it h. So here, this we use the right triangle trigonometry. So we know that sine of 45 degree will give us, sine give us the vertical distance from the diameter. We can think it, we can imagine there's a, we can imagine there's a triangle, right? We can imagine there's a circle around it, like circle here. There's an origin here, right? So this is the vertical distance traveled using radius length as unit. So then we have h divided by 15 feet. So 15 is unit measure in some sense here. How many times 15 can go into h? So then we're solving for h, so we can multiply by 15 both sides. Then we have h equals 15 times sine 45 degree. So sine 45 degree, it can be found, it can be evaluated using unit circle. So it's something you have to be able to construct it, or you can also just have it memorized, whichever you prefer. And we'll go over that in the last page as well. So 15 times square root over 2. Sine 45 degrees square root 2 over 2. So height is 15 times square root 2 over 2 feet. So this is the height. Let me write it better. 15. This is the height. This height right here. So let's go to number 9. Sine theta equals negative 7 over 4. So all these problems, I suggest you draw it. So I'm gonna, again, if you want, please pause the video and try again. And if you have no clue, just watch my drawing first. So sine theta is negative 4 over 7. Okay. So that means we have a circle. Again, sine measures the vertical distance from the horizontal diameter using radius length as a unit. So we divide by radius length. So here we have a radius of 7. Okay, so we can, when we have this, when we do trick, we can also assign negative signs. So these are the same quantity. But we're going to write like this. So we can view radius as always positive length, and negative 4 means we have a negative direction in terms of vertical distance. So in this case, we have radius is 7, but vertical distance is 4. So we have, and theta is in third quadrant. So that means maybe angle somewhere here. And this distance right here is 4. But it will be negative 4 since it's going down. And this distance right here, this segment, the length is 7, this is radius. So again, we're measuring this length, and we divide by radius length to see how many radius do we need to cover this distance. So here's the theta. So now we need to find cosine theta. Cosine theta is this distance, right? Or can also be as this distance as well. Okay, with the same distance. What we need to find is cosine represents horizontal distance from vertical diameter. So, how do you find the length? This is where we have to use the idea of Pythagorean theorem. So let me quickly go over Pythagorean theorem. Pythagorean theorem isn't just c squared equals a squared plus b squared. What Pythagorean theorem tells us is that if I have any right triangle, if I find 3 squares, so I'm going to use this length, the same length, then I'm also going to using this small side length, I'm going to draw a square. If I add these 2 squares, let's say area A and area B, if I add these 2 areas, that area is same as if I were to draw a square with this one. Okay. So this area C, let's say, the area C equals area A plus area B. That's what Pythagorean theorem tells us. It's relating with area, this area of a square. So if I add these 2 areas, that area, sum of these 2 areas, same as area of the C square, this bigger square here. That's what Pythagorean theorem tells us. But how do we find the area? By multiplying the side and height. And a lot of times we assign just letter. So let's look at A, B, C as a length. And that's how we get C square. We call it square because this represents area of a square. Instead of C to the second power, that's why we call it square. A square plus B square. So don't just memorize the formula, know what it means. It means area between relation between area of c square and these two squares adding. So similar to here, we have 7 square equals negative 4 square plus, let's call it unknown variable x. This distance is x. So we call it x squared. So this is 49, 16 plus x squared. So let's solve for x squared by subtracting 16 both sides. Then what do I get? 33. Let's subtract 16 both sides. And this is what I get. So now we have to take a square root. If I take square root, I get either plus minus square root of 33. So here we have to consider, now the distance is actually negative. So that's why actually the distance actually has to be negative square 33. So that means our final answer is cosine of theta, this angle, equals negative square root 33 divided by the radius length 7. This is the final answer. So let me write it here. This is negative square 33. Again, we need to practice thinking what the sine and cosine represent. Sine is the vertical distance measured in radius length from the horizontal diameter. Cosine measures, cosine theta will give us output of horizontal distance measured in radius length from vertical diameter. So same idea here. So pause the video, try on your own, then come back. Oops, so actually, I apologize. They're supposed to be cosine. Doesn't make sense to have a two sine theta and two different values, right? So pause the video, try on your own, and if you're done, come back. So again, I suggest you draw every time you do these problems, especially when you do your own homework as well, right? So let's draw a circle. Circle. So sine theta is negative 5 over 13. Again, I'm going to view this as negative 5 over 13 and negative 12 over 13. So this is sine theta, this is cosine theta. So radius is 13 and let me draw red. This means that the vertical distance from the horizontal diameter is negative 5. So it could be either, well, negative 5 over 13. So it could be here, or it could be somewhere here. We do not know. We do not know yet. Okay. So let's look at cosine to see if cosine can help us narrow that down. Cosine is negative 12. That means cosine length is also negative. Cosine length is horizontal distance from vertical diameter. So negative 12, so it must be somewhere here like this. So we have angle and third quadrant. Oh, let me actually not do that green. So let me draw the measure angle first. The theta is, we can view as somewhere here. Like we can start from here, we have this, or we can also just view this. Either way, we'll get the same answer. So now we have the triangle. So let's label this length. So the green, right, this is negative 12. And this right here is negative 5. And as is shown here, the radius length is 13. and we can think as this is origin. So let's look at the problem tangent. What does tangent tell us? Tangent theta inputs an angle and output is slope. So what is the slope of this line right here? How can we find that? Rise over run. Rise over 1. Okay, so we can let me do a highlighter. So we can start from this point, we go up this much, and we go up this much. Also, we go right to that amount. So it's 5, up 5. Over 12. So this is the tangent value. And again, because this finds slope, which is y over x, tangent y over tangent x, tangent theta is also sine theta over cosine theta. So you can also use this to evaluate tangent. Again, you need to be able to come to it both ways. So tangent is sine negative 5 over 13 over cosine negative 12 over 13. And this also simplifies to negative 5 over negative 12, which is 5 over 12. We got same answer. Secant is just 1 over cosine. And cosine is 1 over negative 12 over 13. So we have 1 over negative 12 over 13. That is same thing as 1 times multiplying the reciprocal. So we have negative 13 over 12. That's secant. So let's look at how we can construct a unit circle. So this is something you need to be able to do so you can find certain sine, cosine, and also tangent values from the quizzes and the exam, and they definitely expect you to know this in calculus class as well. I mean, they expect you to know everything, of course, we talked about, but you definitely need to be able to construct this on your own. So I'm going to give some pointers. So first, of course, draw a coordinate. In unit circle, so draw a circle. That was not good. Let me try again. Let me draw one at a time. It is not easy drawing on iPad. Maybe I just need more time to practice. Okay. So we have 1, 0. This point is 1, 0 in xy coordinate. And as you can see, this is 0, 1. This right here, 0, negative 1, negative 1, 0. So these are just based off on x and y coordinate. Since it's unit circle, this radius length is 1. So how do we construct unit circle? First, we need to draw some angles. So we have 3 angles. Well, excluding the x and y axis, we have 3 angles in each quadrant. Okay. So let me actually to this first angle right here is pi over 6. And this angle right here is pi over 4. This angle right here is pi over 3. Again, I have uploaded like a filled-in version of this on Canvas. So if my writing is too tiny, you can also reference that. So you draw a first quadrant like this. So you do have to remember these 3 angles. Also in degrees, there's a 30 degree, 45 degree, 60 degrees. So and you can also think as extending this line right here, like this and this. This is a straight line. And we'll also have 3 angles here. And we'll fill that in a second. So then here, oops, we have this coordinate. This coordinate is square 3 over 2 over half, comma half. And this coordinate right is square 2 over 2, square 2 over 2. And this right here is half, square 3 over 2. So remember, let me write this. We have x comma y coordinates here, right? And x is cosine of theta value, the angle, and y is sine of theta value. Again, this is because as we define sine and cosine, sine was the vertical distance using radius length. That's why it's y coordinate. Cosine is horizontal distance using radius length. That is why it's x value. And since radius length is 1 in unit circle, we're dividing by 1. So we get direct length. Okay, so we just filled in first quadrant. And how these values are found is using those special right triangles that are shown in the video, right? The module 2 video. So this pattern repeats. Okay, this pattern repeats. So let's do this. Let's go to second quadrant now. So second quadrant also has 3 angles. So you can think it's kind of mirroring. So let me actually leave some room for the angle. So first of all, this angle right here, this angle right here is pi over 2, right? Pi over 2. Keep doing that, man. Okay. So what's the next angle? This angle. This angle right here is pi, 2 pi over 3. So that means we have, this angle is 2 pi over 3, okay? So this is the initial ray. We're implying this is the initial ray for all the angles here right now. Then we're drawing the terminal ray. So this right here, angle is 2 pi over 3. Okay, let me actually draw it better, man. It's really not as easy as I thought drawing. Okay. So this angle right here, so this amount, this open is same. So here's 3, 2 pi over 3. And these angle and these are same angle also. So that means we're actually bringing this, we're actually reflecting this point right here across the y-axis. So this point, the height is same. So we have square 3 over 2. So height is same as this point right here. So square root of 3 over 2. And x value, so this distance, amount is also same as this distance. But because it's negative, we have negative half. If you see that pattern. So just compare these 2 points right here, this one and this one. The height is same. The position of these 2 points, the height is same, right? But the horizontal distance, this one is negative. That's why I put negative half. So that means that we can evaluate sine of 2 pi over 3 now using unit circle. Sine of 2 pi over 3 is square root of 3 over 2. Cosine of 2 pi over 3 is negative half. So as you can see the pattern, then here we have another angle. Now this one will be, let's use the word symmetry, symmetric to this one. Okay, so I'll do another one here. Let me write the angle. This one is 3 pi over 4. So we have this point. Now this point is symmetric to this one right here. So again, the height stays the same, but the x value is negative. Like this. So now we can evaluate sine of 3 pi over 4 and cosine of 3 pi over 4. Okay. See the pattern, right? So same here. Now that one, I'm going to write that angle first. That angle is 5 pi over 6. Yeah, you do have to remember that like this. Oh, let me use different color. So now this is symmetric to this right here. So that means that height is same, right? The vertical height is same, but the x value, horizontal distance, negative. So we just filled in first 2 quadrant of unit circle, and this pattern stays. So only thing you have to worry about is really the first quadrant and all the angles, right? All the angles. Okay. And even in angles, if I give you, so that's not as apparent pattern, but let me go over it really quick. So even in angles, we have, in the denominator, we have 3, 4, 6. 3, 4, 6. But in first quadrant, it's all pi. Second quadrant is 2 pi, 3 pi, 5 pi. So in second quadrant, the top, the numerator angle, the number is 1 less, but we still have to multiply by pi. Okay, so that's one way to think about it. Just a tip to memorize, right? And as you can see, the pattern stays the same. So let me fill the angles here. So we have 7 pi over 6, 5 pi over 4, and you can guess it, 4 pi over 3. So still we have 3, 4, 6 in the denominator, right? Now the numerator part is one number bigger. So 4 is one bigger, right, than 3. Then we multiply by pi. Same here. Okay. So as you can guess it, now let's look at, now this one is, again, we can use the idea of symmetric. So then we use this value. So that means that, let's look at this. This height, amount of height is same as this one, but it's negative. You can also compare with this point as well. Doesn't really matter, we'll get same answer either way. So you can compare these 2 points. Then again, the x, the distance is same because both negative direction. But now y is also negative distance, vertical is negative, so like this. So let's do this one. This point right here, similar idea. This distance is same as this distance, but y is negative now. So instead of positive square root 2 over 2, we write negative square root 2 over 2. And horizontal is same. This distance is same. So I know with all different color it looks kind of messy, but again, I posted the version that I typed. Right now I'm just going over so you can practice constructing this on your own. Okay, so let me fill the rest of it. So this one. Two. And as you can see the pattern, now we can evaluate all these angles. Sine of 4 pi over 3, cosine 4 pi over 3, all these angles. Okay, so then let's look at fourth quadrant. The idea of symmetry still holds, but what are the angles are a little different. The pattern is not as apparent. Again, you could also go in degrees, but again, we need to be comfortable in both degrees and radian. So here again, we still have denominator 4, 3, 4, and 6, right? So how do we get 11, 7, and 4? You can think as 11 is 1 less than twice of 6. Then multiply by pi. So it's 12 minus 1 and pi. 7 is 1 less than twice of 4, which is 8, right? So 7 times pi. 5 is 1 less than 6, so pi. So let me actually move this a little closer to this point. Yeah, I guess I also forgot to write these angles. This is negative 1 comma 0, 0 comma negative 1, sorry. And this angle right here is 3 pi over 2. And this angle right here is pi. And this, yeah, is 0. We can also view as a 2 pi as well. 0 and 2 pi are coterminal to each other. So here, yeah, in order to find this point, I can again use the first quadrant. The vertical distance same. This is same distance. This distance and this is the same. So we have square root of 3 over 2. Now the y value is negative. So same value as first quadrant, but now y value is negative. That's it. So now we can evaluate any of the sine cosine value using the unit circle. So this is very important because this helps us evaluate sine, cosine, and tangent. Because tangent is finding slope. And we can find slope by sine over cosine. Since slope is changing while we're changing x, unit circle tells us how much it changed from 0, 0 to, for example, this point. We just find how much change in y or change in x, for example. So we can use sine over cosine to find slope of tangent. Sorry, slope of the terminal ray. So on the last page, we're going to see how we can use unit circle. So again, it's very important for you to be able to construct this so you can do a problem like next page. Unit circle will not be given in the quizzes or exam. Okay, so make sure you can draw some. Again, I just put it here just for the organization's sake. So when you do this, draw unit circle first on your own. Then looking at that, try these problems. Okay. So pause the video and try on your own as much as you can. Then come back, then I'll go over. So let's look at one at a time. Cosine pi over 6. So in the beginning, I do suggest you write this as a habit. Cosine theta, sine oh man. Let me write it better. It slips my hand. Sine cosine of angle theta and sine of angle theta. Okay, these two. Again, we do not ever just write COS and SIN. It always comes with the input, either theta or tx, whatever the angle variable is. Okay, again, it is important for us to think the angle as a varying quantity, as I said in previous video. Angle can be a varying quantity. It's not always fixed. That's why we want to think as a circle, like a spinning, rather than just a right triangle. It can form a right triangle, but it's not a fixed right triangle. So cosine pi over 6, we look at this angle right here, and we look at x value. So cosine pi over 6 is just square root of 3 over 2. Sine pi over 4, this angle, sine is y value, square root 2 over 2. Tangent pi over 3 is right here. Now we do sine over cosine to find the slope. So slope is y, so this square root of 3 over 2 divided by half gives me square root 3. So slope of this terminal ray right here is square root 3. A little bigger than 1. Or between 1 and 5. 1 and 2, right? So starting D, I'm going to write it here, just out of the room. Secant secant 2 pi over 3. So remember, secant is 1 over sine 2 pi over 3. So what is sine 2 pi over 3? We go to 2 pi over 3. This is, again, very important for you to draw the unit circle next to you when you do this problem in the quizzes, homework, when you do practice also. So it's 2 pi over 3. This is sine value. So we have 1 over square root of 3 over 2. This is the same thing as multiplying the reciprocal. So we have 2 over square root of 3. We usually don't want radical on the denominator. So we multiply square root of 3 over square root of 3. We have 2 over square root of 3 over 3 as the answer for D. So let's look at E. E is actually a really quick summary right here. Pi over 6. Right here, sine is half. Half. Cosine 2 pi. 2 pi is right here. 0 and 2 pi are coterminal. Cosine is 1. Ooh, now next we have negative pi. So let me do G here. First of all, rewrite as in terms of sine, cosine, or tangent if we can. So secant is same as 1 over cosine of negative pi. Now this is where, again, we really need to think the angle as a varying quantity and how it moves along the arc, on the arc of the circle. Again, the way we think helps us the way we understand these concepts to do problems more efficiently and productively. Okay, productively. Whoops. Sorry. Secant is same as 1 over cosine negative pi. So here on the unit circle, we start from here and we move negative pi. So negative pi is this direction. We'll come to here. So now here we look at cosine value. Cosine is x value, so negative 1. So answer is just negative 1. Now tangent 6 pi. Let me do h here. Okay, tangent 6 pi. So 6 pi, if we have 2 pi 3 times, right? 2 pi 3 times. So we have to find the coterminal angle since it's not a unit circle. So 6 pi is coterminal to 2 pi since it's rotating 3 times. If that's confusing, you can just think as, you know what, if I 2 pi plus 2 pi plus 2 pi, it gives me 6 pi. So this is actually the same thing as finding tangent of 2 pi or tangent of 0. So just right here. And what is the slope of this terminal ray? Slope is 0. So answer is 0. So one problem that I forgot to type is converting radian and degrees. Let me just do one example or 1 or 2 examples. So let's do radian to degrees. So when we do this, we have to remember that pi is equivalent to pi radian is equivalent to 180 degrees. So if I want to convert, for example, let's do 2 pi over 3 to radian. I multiply by 180 degree over pi. So here's the important part. This right here, we're multiplying essentially by 1, quantity of 1. That's why we're not changing the quantity, we're only changing how it looks. So this is just like when we change units from inches to centimeters or kilograms to pounds, same idea. We're multiplying, we're not actually changing the quantity, we're only changing the unit. So pi's cancel out. We have 2 over 3 times 180 degree. We get, this is 60, 120 degree. So we saw that 2 pi over 3 equals 120 degree, or 2 radian. Let me just all write it better. I think I'm figuring a little bit out how I can, if I hold the pencil a certain way. Anyway, radian equals 120 degree. And we can verify that here. 2 pi over 3 is same as 120 degree. Okay. So same idea. How do we do degrees to radian? Degree to radian. So let's say I have, let's pick one of the unit circles so we can verify. But again, the idea is same. If I want to do 10 degree, I multiply by, now we want to do pi over 180 degree. Okay, so here we multiply 180 over pi because we can cancel out the pi, right? Well, we don't want to actually think about canceling pi, but if pi is given, it's an easier way to visually realize that. But better way to think about it is because we want to convert to degree, we want a numerator to be degree in this case. But in this case, because we want to convert to radian, right, we want to have pi on the top because pi is in radian when we multiply. So then we have 210 over 180 pi. 210 and 180, we can simplify to 21 pi over 18. Then that is 7 times 3 is 21. 6 times 3 is 18. So 7 pi over 6. And this is right here, this angle. Again, even if it's not a unit circle, you can convert any angles, any radian to degree, any degree to radian using this method right here, these two. Right, there's a homework problem in the MATLAB you can try. So this also can be used to draw a unit circle as well, because it is somewhat easier to recognize pattern of angles in unit circle if we're in degrees. 30, 45, 60. So first we increase by 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30. So you see the pattern here, how angle increases. It's either by 30 degrees or 15 degrees. So you can actually list all the angles in degree first on unit circle if you want. Then convert to radian if the problem you're doing asks for using the radian, like sine of, let's say, is asking to evaluate sine of 5 pi over 4. Right, then you can convert 5 pi over 4 to degrees to evaluate sine of 225 degree, for example. But again, this is just a skill to solve specific sine and cosine and tangent values. But again, it's very important for us to understand the angle as a varying quantity. The openness changes as the terminal ray moves along the arc length, right? Arc of a circle. So that's a very important point, and that's how we define sine and cosine using that idea. Okay, and also understand the angle measure in radians. Using radius length, we measure the arc length, 1 radian or 0.55 radian. There's also a GeoGebra like applet I posted on Canvas. You can play around to get an idea of radian.